Mrs. Pearson has got me to help her out with a video. Hopefully it all goes well. We're going to be talking very quickly. We're going to be going over these quickly, so make sure you use the pause button and rewind button if you need to. We are going to be alternating questions. I will be taking the odd number questions. Mrs. Pearson will be taking the even number questions. All right, so there's two ways to do this question. One way Mrs. Pearson has this written out. This is the formula. This is kind of the nice mathematical way to do it. And as you can see, she's got it labeled with segments. I like to say the top plus the bottom, and then divide by 2 will equal the middle segment. And that's exactly what Mrs. Pearson has here. The top plus the bottom divided by 2 equals the middle. Or sometimes we call that the mid segment. Okay, so she has filled in, divided by 2, and cross-multiplied to come up with this equation, and she solved that equation. Now, that's great. I like that. I am going to show you a little bit of an alternative to this. Okay, a little bit of a cheat, if you will. Just look for a pattern. Look for a pattern. Take the top number and ask yourself, well, to get to the middle segment, what did they do? They must have added 14. Well, if you complete that pattern and add 14 to the mid segment, you should also get 58. Nice. So 2 ways, your choice. Make sure you write that down.
So number 2 is one that I should have to not talk about hardly at all. We all know triangles have 180 degrees. It's really important that you draw the triangle, even though you can do this in your head sometimes and figure out that A plus B plus C does in fact equal 180. When you add the common terms, x plus 2x plus 3x is 6x, and then 2 plus 4 is 6. You solve that, x is 29. Please be cautious that you read the question. In this case, you can stop at x equals 6, but sometimes it will ask you for a different angle measure.
Remember, triangle sum theorem. Okay, number 3. Got a nice transformation question here. First thing I did when I looked at this is try to ask myself what type of transformation this was. And it looked like this was a reflection over the x-axis. A reflection over the x-axis. And I remember that reflections change the orientation or change the lettering. So that's what I'm going to look for in my answer here. Opposite orientation and reflection. Nice. Easy question.
So this we have to recognize an angle bisector for number 4. Please remember, we've done so many constructions, you guys should be used to this by now, but remember when constructing an angle bisector, you need to have what we started calling a reference arc. A reference arc. And once you find that reference arc, then you measure how large that arc is, and you kind of make a little X out in the middle of nowhere. When you do that and you connect, this should tell you that this angle right here and this angle right here have the same measure. So when we look at the choices, and I kind of made a whole bunch of little notes here, if you have a little piece, ABD, which is right here, and it does not equal half of the other little piece. So I made some notes there. You may want to take a look at those notes and write them down. I would suggest that you do that, please. And the answer is choice 2.
All right, here we go with a triangle inscribed in a circle. Now, something that you need to remember about circles and circle properties is that the diameter is the longest chord of the circle. So that means the closer you are to the center of the circle, the longer your segment is going to be. So you can see this is the closest to the center. It's only 2 units away. So this is the long side. So we went around and we labeled. This is the middle side. And this is the shortest side. And you could cheat. You could use your compass to find this. But those are the sides in order now. We've got to put them from the biggest to the smallest. So we want to go from AB to AC to CB. So we're looking for this answer, and there it is, number 1. AB is larger than AC, which is larger than BC.
So number 6 is really, really short. We don't see the word isometry too much in the New Common Core. An isometry is really a rigid motion. We are very brilliant with rigid motions. An isometry keeps the size and the shape the same. All of these transformations keep the size and the shape the same except the dilation. Dilation creates similar triangles.
Okay, we have a question that deals with a triangle, and as you can see, the first thing that we did was to draw that triangle. Okay, we drew that triangle, and it was important to notice that AB was congruent to BC. That's giving us an isosceles triangle. When you draw in your altitude, which makes a 90-degree angle with side AC, in isosceles triangles, it will divide that base into 2 congruent parts. Also in an isosceles triangle, remember, the base angles are equal. So I am looking for all of these things. However, notice in the question, important, italicize. Which one is not always true? Look for the one that is not always true. Pause now, look through the answers, and come back and see if you got it right. Let's hope you came up with choice 3. This is AD is not always congruent to the altitude. They do not have a relation to each other. Onwards.
Mr. Carpenter is extremely upset that I get to do this question because it's an even question. He loves to talk about wee and pee-pee. Please remember, that's what we were talking about. The pee-pee is when you have a piece inside. And actually there's 4 pieces inside when 2 chords intersect inside of a circle. This is actually the wee. This is the exterior pieces. And this is also exterior, and then this is the whole thing. That's the trick for a lot of these questions. Pause the video. Make sure you're writing down these notes. We're not expecting you to be experts on this yet because we haven't spent a lot of time. But we do expect you to know this very well within the upcoming weeks. Pause the video. Take a look at those notes. Make sure you have them written. And when you go to find the answer should be choice 4.
All right, this question, first thing that sticks out to me is what angle pair these are. And as you see, we have labeled these corresponding angles. So keep it simple. I'm going to look through the options that I have, and I'm going to look for something that says something about corresponding angles. Let's see. There it is, corresponding angles. So this one was a straight identification question. If we made that recognition, question became very easy.
Okay, we're at number 10. We've kind of talked about number 10 a little bit. Again, circles are something that we're not experts on right now. This is the equation of a circle right there. This is the equation of a circle that's actually not having a center at the origin. So basically what we've got is some sort of circle that has a center at -2 positive 3, and so it comes around and radius is 5, so it's going to look probably something like this on the graph. What it means is we want to put the opposite sign of negative 2 inside a set of parentheses, and the opposite sign of B inside a set of parentheses. The biggest thing to remember is that you're squaring the radius, so if the radius is 5, then the ending number is going to be 25. We touched base on that a little bit. We will become experts on that very, very soon.
All right, number 11, Mrs. Pearson has marked with a bonus. Okay. What I would say to you is, if you were doing this on a Regents, what I would do is take that sheet of extra graph paper in the back of the Regents packet and draw a picture. It says town A and B are 16 miles apart. Okay, so on that graph paper, just put 2 points that are 16 squares apart. It doesn't matter if they're vertical from each other or horizontal, just as long as that they are 16 units apart. And then if you want to be 10 miles from town A, what you would do is count 10 boxes towards B, 10 boxes up, 10 boxes to the right, and 10 boxes down, and that will put you in a circular, what we call locus, circular pattern. Now we do the same thing for B. This time, though, I have to be 12 miles from B. Well, if I go 12 miles, I will be more than halfway to point A. And when I draw that circle, you can see Mrs. Pearson's is the same as mine. I get some overlapping of those 2 circles. And what that means is there are 2 places that this could be located at. Something a little bit new, but you could use graph paper. I think it would really be beneficial for you. All right, Mrs. Pearson had an engagement, so I'm going to take over the next couple. I'm hoping to get to number 14, and we're running a little bit long on this video, so we're going to have to make it into 2 parts. This will be part 1. Number 12 deals with points, lines, and planes. Early in the year, we dealt with points, lines, and planes, and this one is, again, very geometrical. And what I mean by that is you have to do a lot of mental thinking and imaging to come up with a good picture for this. I'm going to try to draw a picture and demonstrate. J and K intersect at point P. So I'm just going to draw 2 lines. Whoops, there was the answer. Okay, so there's the answer. If I draw 2 lines like this, J and K, and they intersect at point P. So think of just those lines being on a flat sheet of paper. The only way that I can get M to be perpendicular to J and K, if it would be sticking out of the paper, imagine a 3D visual, if you will, of sticking your pen straight through a piece of paper. Those 2 lines, J and K, are on the paper, but your pen is actually sticking straight out of the paper. And that's what I'm trying to demonstrate here. This is coming straight out of the paper, and it is perpendicular to both of these lines. So think of maybe like a skewer that's going through the center of a sandwich. It's kind of coming straight down through that and holding everything together. So what we're finding out is that M, as you see, is perpendicular to that sheet of paper or perpendicular to that plane. Well, we were hoping to get through question number 14 halfway, but we reached our max time of 15 minutes. So we're going to have to cut this video short. I will have to learn how to talk quicker next time, but see you in part 2.